We'll now start session 3 of our closing event. In session 3, we will present the project pilots of our StepUP project. Moderator for this session is Melinda Rova. As said earlier, she's senior consultant at ABUT, which is Advanced Building and Urban Design. Melinda, the floor is yours.
Okay, so I'm happy to lead and moderate this last session of the day, which concludes our project. The last session will be about the pilot activities, which are an integral part of our project, as we can test and validate the achievements throughout of our different technology and tool developments in a real environment. And testing in a real environment can be can bring some quite unexpected challenges, but also can be very rewarding to see the end result in real life and used by their building owners and end users. So I would like to present our first pilot owner, Zsófia Regula, who is representing the 18th district of Budapest municipality. She is a project manager at the municipality, overseeing different construction works related to public procurements and the building stock of the municipality. And in the StepUP project, she coordinates the Hungarian pilot site. She has been present at the construction from the very beginning until the kindergarten employees and the children could take over all the new functions in the building. So, Zsófi, the floor is yours.
Just a moment. So good afternoon, everyone. I would like to start by saying thank you for being here. My name is Zsófia Regula, and I'm here today representing BP 18, the municipality of District 18. Here you can see the index of my presentation. So our Hungarian pilot, the Zöld Kindergarten, is located in Budapest, Hungary, more specifically in District 18. The building is more than 70 years old and it has long surpassed its prime. The renovation had a lot of challenges because of the building's old age, a 415 square meter facade and the heating system that is not only obsolete but also very impractical. The existing open combustion atmospheric standing furnace coupled with a 60-year-old cast iron radiator had made it nearly impossible to regulate temperatures in each room, affecting approximately 100 children, some of whom are living with autism. Understandably, temporary relocation during the time of the renovation was not an option, so we managed to renovate with a fully operating kindergarten. To tackle this complex issue, we implemented a two-phase approach using the StepUP methodology. Our selection process, facilitated by the portfolio overview tool, led us to Zöld Kindergarten. It's a representative case highlighting the urgent need for deep renovation in public buildings. This tool displayed an overall picture of our district's public buildings, ranking every building by its current condition and need for renovation. We also introduced data intelligence by incorporating an array of sensors, including CO2, temperature, and humidity sensors within the classrooms. These sensors, coupled with technology that tracked the opening and the closing of the doors and the windows, played a pivotal role in the project. And by analyzing the data collected, we were able to devise a tailored heating and cooling schedule that not only can enhance energy efficiency, but also can significantly improve the overall comfort levels within the kindergarten. This approach allowed us to monitor and measure the impact of our renovations with precision. With the Lean tool, we measure time on site and the amount of incorporated material, So basically, it was a new platform for all of us for communication, for transparency, ensuring minimal disruption to the kindergarten's operation. Throughout both phases, we conducted a comprehensive comfort survey using tables fixed in each room, allowing us to measure thermal comfort 3 times a day. So the nurses had to, sorry, the nurses had to tap on the tablet and say their comfort level in the morning, at noon, and in the afternoon too. By comparing the subjective assessments with the ambient sensor's objective data, we were able to calculate the total comfort experience, and simultaneously gas consumption was monitored in advance, providing us with valuable insights into the project's efficiency. So these are some pictures how the kindergarten looked like before the renovation. It may seem nice at first glance, but the kindergarten's walls were weathered and worn down. The walls were cracked all over the place, and without proper insulation, they basically left the interior exposed to external effects. The critical concern was the heat loss at the facade and at the roof, rendering the building an inefficient energy consumer. In phase 1, we introduced the plug-and-play envelope system with laser-measured prefabricated wall insulating modules, and later the roof also got a traditional insulation. After several preparatory works, like dismantling the entrance canopies, relocating the terrace pergolas, and raising the wall height of the main facade with a steel structure, the first step was to measure the location of the panel fixing brackets. Then we fixed them onto the facade. During the planning phase, the experts carried out several measurements to verify the load-bearing capacity of the walls, and we also tested the load-bearing capacity of the roofs before putting on the solar panels. As the next step, the prefabricated thermal insulation panels were installed, which were provided by Manni and Isopan. And to eliminate the thermal bridges, the contractors closed the doors and window junctions with additional mineral wool insulation. The outer covering was provided by colored cut-to-size HPL plates, which were attached to the aluminum profiles with pop rivets, and windows were given uniform metal elbows. Thanks to the technology, the number of on-site work processes can be minimized, and the need for human resources is also reduced, so the contractors get things done much faster, basically. This technology not only saves time, but also reduces disturbing environmental factors such as noise and dust created by the renovation, which in our case was very important because I mentioned before the kindergarten was open and fully operating while we were doing these steps. And by using prefabricated solutions, the risk of errors arising from on-site construction can be minimized since the individual elements are made in the factory under controlled conditions, subject to strict quality control. Moving on to phase 2, we implemented the plug-and-play active system and third-party heat distribution, including PV elements. This phase introduced a new technology featuring the building energy management system, driven heat pump, and an intelligent heat tank. So we initiated the renovation by conducting extensive demolition work, during which we dismantled the outdated heating pipes and radiators. Throughout the renovation process, we replaced the old gas boiler system with an energy efficient heat pump system. And these heat pumps serve both heating and cooling purposes, capable of generating water up to flow water up to 60 degrees, even during the coldest winter days. Additionally, we installed a solar system on the roof to cover the average energy consumption. The integration of a smart grid-ready heat pumps ensures optimal utilization of solar panels. Any surplus energy generated by the solar panels is utilized by the heat pumps and stored in the buffer tanks for later use. These buffer tanks, specifically heat tanks, as Zoltán mentioned, are individually tailored to the project's requirements by the manufacturer. To optimize energy efficiency and ensure maximum comfort, we combine the heating and cooling systems throughout the entire building using radiators and fan coils. The fan coil heating cooling system was installed with a focus on quiet operation, because of the children, employing fan coil devices with low rotation speed. The distribution of the heating cooling mainline was achieved using freely installed pipes, concealed in some areas with false ceiling for aesthetic purposes. In addition to passive energy savings achieved throughout thermal insulation, this renovation actively contributes to reducing the building's energy consumption. Calculations indicate that 32% reduction in heating energy demand solely through thermal insulation, with the overall energy consumption reduced by 77% throughout the renovation process. In conclusion, our pilot project is not only just a renovation. I think it's a testament to our commitment to sustainability, efficiency, and most importantly, the well-being of our community, including the children who depends on us. Thank you for your attention.
I would like to move on to the next presentation. Maria Ibanez is the head of R&D project in ACERE Constructions. She holds a degree in building engineering and a PhD as well. During her career, she has worked on several energy efficiency and sustainability related projects, especially focusing on adaptive and active facades. She has participated and managed several research projects, starting from local, regional, or national funds, and even European Union funded projects as well. And she is also author of several scientific papers. So Maria, the floor is yours. Please start your presentation.
Good morning, everyone. Thank you, Belinda, for the presentation. And thank you for the opportunity to share with all of you the Spanish pilot experience. I am Maria. I work for ACERE, which has been the partner in charge of the Spanish pilot. Here you can see the index of presentation. And according to the Crown Agreement, the Spanish pilot must be focused on three main pillars: deep renovation needs, public grounds, and it must be a multi-owner residential building. Regarding these three main pillars, ACERE started searching for the best pilots, and the first option was identified in January 2020. It was the renovation of one of the towers of Ciudad de los Periodistas, which is a huge neighborhood in Madrid. However, due to the uncertainty situation of that time, due to the COVID-19 situation, they decide to postpone the renovation. So we start to look for a new pilot, and in July 2020, the renovation of Monasterio de Urdax in Pamplona seems to be the most feasible Spanish pilot. However, it has been impossible to do the renovation within the timeline of the StepUP project. In this occasion, the neighbors were really committed with the renovation, with us, with the project. In fact, we monitor the energy performance of the building before the renovation. They apply for other public grants to make the project affordable, and they also apply for the construction permits. However, in January 2023, we were still waiting for those permits, and the StepUP project could not afford more waiting time. That's why a plan B was designed to be able to demonstrate the StepUP impact. And in this case, two small pilots were proposed to demonstrate the application of the StepUP technologies and then correlate the results with a real building, taking Monasterio de Urdax as the baseline. Therefore, we designed a specific pilot to install the facade plug-and-play solution and another to integrate the active plug-and-play solution. The first Spanish pilot are two test cells located at the R&D facilities of the University of Navarra in Pamplona. We don't need any permits nor grants to do the renovation, so the facility provides a good opportunity to renovate the test cells using the plug-and-play facade solution, and the most important thing, evaluate the time on site. The second pilot is a multi-use building property of ACR that we use as a canteen, as a storage for the company, and above all, it holds the server room of the company. In this case, the idea is to integrate the heat tank technology to cool the server room, and therefore demonstrate the application of this technology for cooling needs across Europe. The idea of the first pilot is to renovate both the cells using the plug-and-play facade solution, and also validate the integration of different third-party technologies. In this case, we integrate windows and PV panels. The objective is to evaluate the time of the installation and compare it with a conventional facade solution. The principal difference between this pilot and the Budapest pilot is that in that case we have 2 floors instead of just the ground floor, and we also need to solve the corner elements of the building with the plug-and-play solution. Each test cell has 79 meters square. That means a total of 158 meters square of renovation. Each floor is solved with, as you can see here in the plan, with 5 plug-and-play modules and 4 corner elements. That means, that makes a total of 36 plug-and-play modules for both test cells. So the first activity of the installation consists of removing the external layer of the facade that the test cells already have. Then all the anchor elements were installed. Here it's important to highlight that for this specific building, we have to adapt the solution of money. The test cells structure is made by steel, so no concrete is there. So the anchor elements, as you can see in this photo, must be welded to the structure, eliminating one of the fixing screws of the solution of money. That means that one of the adjustment of the solution is completely blocked. And here you can see or find some photos of the installation process, the shipment, the lifting, then you have to adjust of the modules, and then you install the upper module. The objective of the second pilot is to integrate a cooling system with a storage capacity into the HVAC system that already exists in the building, without direct connection with the refrigerant liquid. That means that the connection in the installation is made through the air. The idea here is to demonstrate that we can cool the server room here in the plans, optimizing the electrical consumption. Here, I share with you the installation diagram, the main idea, the focus of this pilot, and the key element here is the heat tank, which can store the cold. Is the main idea of this installation. Obviously, we need to charge this heat tank, and in order to do that, we take the cold air coming from this inner unit. You can see the greener part of the scheme. And to take that cold, avoiding refrigerant circuit, we need a specific heat exchanger. This heat exchanger is able to transfer the air from the inner unit to the heat tank, and we accumulate that cold there. We do this process when the electricity is cheaper. And then when there is the server room needs cool, the discharging heat exchanger turns on, and we discharge the heat tank. That's the idea of the installation. And I shared with you some photos of the installation. On the left side, you can see the heat tank with all the connections, electrical connections that we need, and all the pipes and the valves. And on the right photo, it can be seen in detail the inner HVAC system, which is the provider of the code, and then just attach the charging unit, change the air and transfer it to water and to the tank that is right here below. And on the other side of the installation, we have the server room here and the discharging unit that is similar to the one installed near to the heat tower. It is true that these two small pilots are not comparable to the original idea of the proposal for the Spanish pilot. Nevertheless, we are convinced, the StepUP project are convinced that the pilots have contributed to an in-depth knowledge of the StepUP plug-and-play technologies, being not only the perfect complement to the Hungarian pilot, but also allowing new applications to be explored. We have already finished the installation of both pilots, so we don't have too much time to analyze the solution. Nonetheless, there are some general conclusions that I would like to share with you. Related to the plug-and-play solution, the plug-and-play facial solution, in general terms, it can be said that the installation ratio is quite similar or even better than a conventional solution. However, it would be necessary to optimize the installation process in order to make it easier to assembly, especially if we like to renovate buildings with more than one floor, like exterior works. And related to the active system, as I mentioned before, we don't have enough time to evaluate or to analyze the energy performance of the system. However, we have demonstrated that the installation of this disruptive technology is possible and feasible. And in fact, to give you a specific figure, the installation and commission of the entire installation has been done in a single week. So it's a really promising solution. Thank you very much for your attention, and do not hesitate to share with me your doubts or questions.
Thank you, Maria, for your presentation. As you said, everyone can submit their answers in the chat. And now I would like to introduce the last presenter of today's conference, Giulia Barbano from IES. Julia is the R&D operation manager in IES with many years of experience with research and development projects as coordinator and technical leader. And she has worked in many projects with a sustainability focus, especially renovations as well. So Julia, the floor is yours to introduce the last pilot in the project.
Thanks. Thank you, Melinda, for the introduction. The last pilot of the project is a virtual pilot. What do we mean by that? Basically, this is the Helix building in Glasgow. This is the headquarters of IES. It's our office, and it's not a building that we own. We rent it, so we don't have the capacity, the ability to the power to renovate it, for example. Yeah, but we have some margin of intervention, and so the interesting demonstration in this building is to look at this pretty common case. Yeah, you have an office building that's rented, so you have these split incentives between the occupant and the building owner to try and look at what is the potential of intervention on these buildings and what you can do in these cases. So in this case, the idea was to test the solutions through virtual modeling, through the digital twinning solutions, and look at how and what could be done in terms of improving the efficiency and what ECMs could be deployed there to make that business case. So it is an office building. It's a pretty typical open plan work office. It's recently built, so it does perform pretty well in terms of the envelope and the heating system. As you can see, it's 15 years old. We have IoT sensors in every room. also in the open plan workspaces, there's more than one, and we have heat and electricity meters. Heating comes from a biomass boiler and then distributed to the radiator system, and there's no cooling because, well, it's Scotland. And we have, during the project, across both StepUP and the sister project IBCom, we have looked at advancing the monitoring systems to really improve the operational use of energy. So this means installing smart TRBs on the radiators, monitoring and control systems for the boiler, and any renewable technologies on site. So we have this virtual model built in BE, that digital twin, and we have used it then to test and improve the calibration tool that I mentioned earlier when presenting the software solutions. Now, the calibration tool helps calibrate the model with real data. So that means that the model then becomes more accurate, and it's a good predictor of the actual performance of the building. So as part of StepUP, we added sensitivity analysis, parametric optimization to this tool. The reason was to make sure that the stakeholders of design and implementation would be able to quickly carry out this calibration exercise. So the sensitivity analysis functionality, for example, what it does is that it looks at the parameter ranges, and then it links to the real data. So the simulated data is linked through iScan to the measured data. So we can compare simulation and measurement and look at the impact that the variables have, the simulation variables have on the calibration metrics. So the relevance of a specific variable on making an accurate model, basically. And then the parametric optimization part allows to provide these ranges for models, parameters of the models that are unknown. And this helps optimize the values and understand which is the optimal value for this parameter to use in the model and make it more accurate. So as I said, it's a virtual pilot. We have not done the interventions here per se, but we've looked at the iterations and different interventions as you would, for the other pilots, and as following the methodology, the StepUP methodology. So we have, based on using the digital twin of the pilot, same processes we did with all the others. We have looked at started from a calibrated model, and then on top of that have added different iterations of interventions. So this has been done as well, of course, in the Hungarian and the Spanish pilots. So here we looked at the realistic interventions that make sense for a building such as the Helix building. So as I said, the energy, the envelope is pretty good. The windows are pretty good. So we looked at the lighting efficiency. So like, for example, replacement wherever possible to LED lamps. We looked at the potential to install PV panels on the roof, and then optimizing the temperature set points. Now, the LED lamp replacement has a small improvement on the electricity. We see a 1.7% improvement from the baseline with the interventions. PV panels actually shave off a good chunk of electricity demand. It's over 12%, which is good considering, again, the location. In Glasgow, it is a bit difficult to produce good amount of power from PV, of course. And we see a very good reduction from the optimization of the temperature set points. That has only biomass demand, it's reduced by 24%. And indeed, as I said, like this was a virtual pilot approach, so these were not foreseen interventions as part of StepUP, but these things have now started to happen in the Helix building, because we see, and we do see actually from these results of the virtual study that these are interventions worth doing. So I think in particular, I think the PV, we actually have installed PV panels just a couple of weeks ago. So that's it for me on this pilot. It's a definitely shorter presentation than the others, because of course a virtual pilot, but happy to take any questions.
Thank you, Julia, for your presentation. And I think to finish this session, we can move on to the questions. So please, you can still submit your questions for the pilot leaders. Okay, let me just check the questions. Zsófi, I would like to start with you. We have a question about the Hungarian pilot. So as the building has been in operation for quite a while now, so you have finished the renovation of the facade last autumn, and the heating and cooling system at the beginning of this year. You have some results for now. So can you give us some first impressions how the building is operating now, and what kind of feedback the users gave you about the newly renovated building?
Yeah, of course. Thank you, Melinda, for the questions. So everyone's right now is very happy that we finished the renovations. It took up a whole year, so it was a long time to finish everything. But right now they can fully operating again in calmness. Thank God. I think it will be a learning curve to learn all of these new technologies that they are using right now, because as I have mentioned before, they have new heat pumps, and we have building management system. So the kindergarten nurses and the head of the kindergarten, they can access it on the internet, and right now they are learning how to use it. Of course, we had a session when when we showed them everything that they had to know about it. But everyone's really happy. The heating was very good during the colder months. We finished, I think, in the beginning of February, and right now there have been no complaints so far. And also the closing event was in 2 or 3 weeks, I think. It was at the end of March, and I was really surprised because a lot of parents came, and they had so many questions about the renovation, how we do it, why we did it, and what's it gonna be like. But they were really happy with the results too. One thing that's very close to my heart is the color of the building, because right now it is green, of course. But in Hungarians, in English, zöldliget kindergarten means it's like a green meadow or a green park. So right now, the building is true to its name. And yeah, right now everyone is really happy. We are hoping for great results during the summer months because it was really, really warm inside the building during last summer. So I hope everything will go well. But yeah, we've got really positive reviews so far.
Thank you, Zsófi. And I have another question that, yeah, as you mentioned, the end results are positive and the building use is very positive, but I can imagine that during renovation, there were some challenges that came up with actually applying new technologies that the constructors, the installers may not known before. So can you tell us about what you think was were the main challenges during this installation process?
Yes, of course. Thank you, Melinda. So of course it was a new technology. So our Hungarian constructors haven't worked with this one before. Of course we used sandwich panels before and stuff like that, but this was something really new. So it was a long learning curve. If we say, I don't know, it took almost a month to get to know this new technology and find out what were aimed with it. And of course, I think our biggest challenge was the fully operating kindergarten. So it wasn't the technology itself, but it was something that something other than that, because you know, for the children, we had to provide the sleeping time. It was 2 or 3 hours every day, so it took a lot of communication and a lot of time management from both our side, from the kindergarten side, and from the contractor side to manage these things together. And we've got really bad weather during the first phase of the renovation. So there were a lot of rainy days, but I think everything came out good. But yeah, I think communication was our biggest issue, but it also was the key for the project to get finished. Also at the second phase, when we were renewing the cooling and heating, ACR has developed an application for us that we could use, so the contractors can sign in, and they could make note of what they are working on at that time. And I think that was really helpful, because if both the head of the kindergarten and both the project manager had access to that application, then we could see how when we are standing at the project, and we can communicate and manage better with that. So thank you.
And just a last question, what would be your recommendation for a future project who would want to start a renovation with the similar industrialized technologies?
I think you will really need a good project manager who has a lot of time and who can be very efficient in communication. Definitely use this application, because it was great for us. And also it will take a lot of learning, but in the end it will worth it, I think.
Okay, great. Thank you so much. So the communication is a key. That's a good point
Yeah.
to close the questions towards you. But I also have some questions to Maria. So, Maria, as you mentioned, you just finished the installation, so you don't have too much feedback so far from the users, but I'm pretty sure that you have collected the feedback from the installers. So can you give us some insights of how they were thinking about the technologies?
Yeah, for sure. I agree with Sofia. I think the main challenge of the installation of both pilots were the coordination between the technological providers and the installers, try to understand the solution and how we have to install both solutions. And I have to admit that in both cases, we have to manage with some important challenges during the installation process, especially during the installation of the plug-and-play solution or the facade plug-and-play solution. Found a lot of some drawbacks on during the process, and we have to learn a lot of things about the technology. But I think it's a really good opportunity. The feedback that we gather from the installers here is a really good opportunity for money and for the project, in order to improve the solution and to make the solution more ready for the market.
Yes, thank you. And you mentioned regarding the active system installation. You mentioned that the installation was quite efficient time-wise as well, and it could be done very quickly. So and you mentioned that you hope to use this new technology in your building. So can you tell us what you imagine as some future applications for the technology?
Yeah, for sure. I think the active system is a technology with great potential for applications where the cooling demand is constant or really high, such as the server room, like in the case of the Spanish pilot. So I think we have a huge market there. Also, Sultan said this during his presentation. And in addition, with this prototype, I think that we can lay the foundations to design new applications for buildings, for renovation buildings, in the cooling side, that I think is a huge important opportunity across Europe now with the climate change.
Okay, thank you so much. And Zsófi already mentioned communication as the key as a recommendation for future projects. Do you agree with this, or do you have any other recommendations for projects who would be willing to install these kind of technologies?
Yeah, I agree with Sophie. I think the communication and for sure the lean methodology can help us to implement this type of plug-and-play solutions, prefabricate solutions, because we take into account not only the constructions activity, the work on site, but we have to take into account also the production process, the supply process. So I think that lean is a key factor for this collaboration and for the implementation of these new technologies.
Great, thank you. And now, lastly, I think we have a last question for the virtual pilot. So, Julia, what do you think? What was the biggest value of the virtual pilot in testing and using the Helix building in StepUP?
Yeah, thank you, Melinda. So I think it was interesting in looking at the very specific room level impact of things we could do, even just changing the patterns of views and advising the users better on what to do. But it was also valuable in looking at the potential savings of interventions that are in the remit of renters, like in our case, like changing the LED lights, etc., but comparing those against things like installing PV panels, making the case to be able to make that investment and to talk to the building owner and so on. So overall, it's an interesting instrument in helping map a roadmap to reducing the CO2 emission of the building and helping make the case for interventions and actually doing them and delivering them in the building.
And regarding the project, the StepUP project and its tools and technologies, what do you think where this pilot helped the most in the development and refining of our technologies?
I think it was, well, definitely for all the data intelligence solutions, it was using depth, but to be fair, it was pretty evenly across all the pilots. The data intelligence solutions have been used extensively in the real infrastructure pilots equally. So we've tested different things in all of them. We had an amazing amount of data coming from the Spanish pilot and the Hungarian pilot as well, So it was possible to do all of these analysis and tests across the board, which has made the solutions more robust overall, because it was not limited, to just the virtual pilots.
Okay, thank you. And I think this was the last question for this session. So thank you everyone for your presentations and the audience for listening and joining the conversation. So now I would like to give back the word to Miguel to close down today's conference.